According to the National Electrical Code, circuit breaker panels should be located at least 10 feet away from above-ground poles. This 10-foot distance is crucial to prevent electrical shock hazards, especially in situations involving water leaks or accidental contact with the pole. The distance from the meter to the circuit breaker panel is not explicitly defined in the NEC. However, keeping this distance minimal is generally recommended. Reducing the distance helps minimize voltage drop, ensuring the electrical panel operates efficiently and reliably. Installing an additional ground rod at the new circuit breaker panel location is advisable, even if a ground rod already exists at the metering or main point. This provides enhanced grounding protection for both the pool and other electrical equipment connected to the panel. When installing multiple ground rods, they should be spaced at least 6 feet apart to maximize their effectiveness. For the pool circuit, a ground fault circuit interrupter, or GFCI, breaker is mandatory. This protects against electrical shocks by quickly cutting off power in the event of a ground fault. For the recreational vehicle, or RV, receptacle, a 240-volt circuit with an appropriate amperage rating is necessary to handle the power demands of the RV. Considering these guidelines, a recommended installation plan is as follows. Firstly, install the circuit breaker panel approximately 40 feet from the meter or main point. Secondly, install an additional ground rod at the circuit breaker panel location, ensuring it is spaced at least 6 feet away from any existing ground rods. Thirdly, connect triplex number 2 underground aluminum wire from the meter or main to the circuit breaker panel. Fourthly, install a GFCI breaker specifically for the pool circuit. Fifthly, install a 240 volts breaker and receptacle designed for the RV. Sixthly, maintain a minimum distance of 10 feet between the circuit breaker panel and the above-ground pool to comply with NEC regulations and ensure safety. Installing a circuit breaker panel requires careful consideration of several factors, primarily focusing on safety and adherence to the National Electrical Code, or NEC. The NEC provides specific guidelines for electrical installations to minimize risks such as electrical shocks and fires. When positioning a circuit breaker panel relative to an above-ground pool, the NEC mandates a minimum distance of 10 feet. This requirement is in place to prevent electrical hazards that could arise from water exposure or accidental contact. Water is an excellent conductor of electricity, making it crucial to keep electrical equipment far enough away to prevent potential shocks. Consider a scenario where a pool pump malfunctions, causing a short circuit. If the circuit breaker panel is too close to the pool, the fault could create a dangerous electrical path through the water, endangering anyone in or near the pool. The 10-foot rule is intended to provide a buffer zone, reducing the likelihood of such incidents. In addition to distance requirements, proper grounding is essential for electrical safety. Grounding provides a low-resistance path for fault currents to flow back to the source, allowing the circuit breaker to trip and de-energize the circuit. This helps prevent electrical shocks and minimizes damage to equipment. Installing an additional ground rod at the new circuit breaker panel location is highly recommended. While the metering or main point may already have a ground rod, adding another one at the panel enhances the overall grounding system. Multiple ground rods provide a more robust and reliable path for fault currents, improving the effectiveness of the grounding system. The NEC specifies that ground rods should be spaced at least 6 feet apart. This spacing ensures that each rod effectively dissipates fault currents into the earth. When installing ground rods, it's important to drive them deep enough into the soil to reach a point where the soil is consistently moist. This ensures good electrical contact with the earth. The depth requirement can vary depending on local soil conditions, but typically ground rods should be driven at least 8 feet into the ground. The connection between the ground rod and the grounding conductor should be made with a listed connector suitable for direct burial. This ensures a reliable and corrosion-resistant connection that will last over time. For the pool circuit, a ground fault circuit interrupter, or GFCI, breaker is required. A GFCI is a sensitive device that detects even small imbalances in current flow. If it detects a ground fault, it quickly trips the circuit, cutting off power in a fraction of a second. This can prevent serious electrical shocks. GFCI protection is required for all electrical outlets and equipment within a certain distance of a pool. This includes outlets for pool pumps, lighting, and other accessories. The NEC specifies the specific distances and locations where GFCI protection is required. For the recreational vehicle, or RV, receptacle, a 240-volt circuit with an appropriate amperage rating is needed. RV typically require a higher voltage and amperage than standard household appliances. A dedicated 240-volt circuit ensures that the RV can operate all of its electrical equipment without overloading the circuit. The amperage rating of the circuit should be based on the specific requirements of the RV. Consult the RV owner's manual or a qualified electrician to determine the appropriate amperage rating. The wiring for the 240 volts RV circuit should be sized according to the NEC ampacity tables. These tables specify the allowable ampacity of different wire sizes based on factors such as the type of insulation, the number of conductors in a raceway, and the ambient temperature. It's important to use the correct wire size to prevent overheating and potential fire hazards. The receptacle for the RV should be a heavy-duty, weather-resistant type designed for outdoor use. It should also be equipped with a cover to protect it from the elements when not in use. The connection between the meter or main point and the circuit breaker panel should be made with appropriately sized conductors. In this case, number 2 underground aluminum wire is being used. Aluminum wire is a common choice for underground electrical feeders due to its cost-effectiveness and corrosion resistance. However, it's important to use the correct type of connectors and installation methods when working with aluminum wire. Aluminum wire expands and contracts more than copper wire, which can lead to loose connections over time. Using connectors specifically designed for aluminum wire can help prevent this problem. The underground wiring should be buried at the appropriate depth according to the NEC. This protects the wiring from physical damage and ensures that it is not disturbed by digging or other activities. The NEC specifies the minimum burial depth for different types of wiring and applications. Installing a circuit breaker panel is a complex task that requires a thorough understanding of electrical codes and safety practices. It's always best to consult with a qualified electrician to ensure that the installation is done correctly and safely. A qualified electrician can assess the specific site conditions, determine the appropriate wiring and equipment, and ensure that the installation complies with all applicable codes and regulations. Attempting to install a circuit breaker panel without the proper knowledge and experience can be dangerous and can lead to serious injury or property damage. Remember, safety should always be the top priority when working with electricity. When planning the installation, consider the overall layout and accessibility of the electrical components. The circuit breaker panel should be located in a dry, well-ventilated area where it is easily accessible for maintenance and repairs. Avoid locating the panel in areas where it could be exposed to moisture or extreme temperatures. The panel should also be mounted securely to a wall or other stable surface. The interior of the circuit breaker panel should be neatly organized and labeled. Each circuit breaker should be clearly labeled to indicate the circuits that it controls. This makes it easier to identify and troubleshoot problems in the future. Use the circuit directory to document the circuit assignments. The circuit directory should be kept up to date as circuits are added or changed. When working inside the circuit breaker panel, always turn off the main breaker to energize the panel. This reduces the risk of electrical shock. Use a voltage tester to verify that the panel is energized before touching any wires or components. Wear appropriate personal protective equipment, or PPE, such as safety glasses and insulated gloves. Before making any connections, carefully inspect the wiring and equipment for any signs of damage. Replace any damaged wires or components before proceeding with the installation. Follow the manufacturer's instructions for all wiring and equipment. This ensures that the installation is done correctly and safely. Double-check all connections to make sure they are tight and secure. Loose connections can cause overheating and potential fire hazards. After the installation is complete, thoroughly test all circuits to make sure they are working properly. Use a multimeter to check the voltage and current on each circuit. Look for any signs of overheating or other problems. If you find any problems, troubleshoot them immediately. Do not leave the installation until you are sure that it is safe and reliable. Keep detailed records of the installation, including the wiring diagrams, circuit directory, and test results. This information will be helpful for future maintenance and repairs. Regularly inspect the circuit breaker panel and the electrical system for any signs of wear or damage. Replace any worn or damaged components promptly. Schedule regular maintenance inspections with a qualified electrician to ensure that the electrical system is operating safely and efficiently. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following these guidelines and consulting with a qualified electrician, you can ensure that your circuit breaker panel is installed safely and reliably. The principles outlined are designed to mitigate risks associated with electrical systems near water sources. Understanding and adhering to these guidelines is crucial for ensuring the safety of individuals using the pool and preventing electrical hazards. Proper planning, installation, and maintenance are key to maintaining a safe electrical environment around pools and other water features. Furthermore, it is crucial to remain updated with the latest revisions and amendments to the NEC, as electrical codes are periodically updated to reflect advancements in technology and safety practices. Consulting with local electrical inspectors can also provide valuable insights and guidance specific to the region, ensuring compliance with local regulations and requirements. A proactive approach to electrical safety coupled with ongoing education and awareness is essential for minimizing the risk of electrical accidents and promoting a safe environment for everyone. Regular inspections by qualified professionals can identify potential hazards before they escalate, allowing for timely repairs and preventative measures. Educating pool users about electrical safety practices, such as avoiding the use of electrical devices near the pool and recognizing signs of electrical problems, can further enhance safety awareness and reduce the likelihood of accidents. By fostering a culture of safety and prioritizing electrical safety in and around pools, we can create a safer and more enjoyable environment for all. In addition to the technical aspects, it's worth noting the importance of public awareness campaigns and educational programs that promote electrical safety around pools. These initiatives can help raise awareness among pool owners, operators, and users, empowering them to take proactive steps to prevent electrical accidents. Collaboration between electrical safety organizations, pool industry associations, and government agencies can amplify the reach and impact of these campaigns. Furthermore, integrating electrical safety education into school curricula and community programs can help instill a culture of safety from a young age. By investing in education and awareness, we can create a society that is more informed and proactive about electrical safety, leading to a reduction in accidents and injuries. In addition to the practical steps outlined above, it's also important to consider the psychological aspects of electrical safety. Fear and uncertainty can often lead to inaction or incorrect actions in emergency situations. Providing clear and concise information, along with practical training, can help individuals feel more confident and prepared to respond to electrical emergencies. Simulation exercises and drills can also help reinforce safety procedures and improve response times. By addressing the psychological barriers to electrical safety, we can empower individuals to take control of this safety and protect themselves and others from harm. Electrical safety is not just about following codes and regulations, it's about creating a culture of awareness, responsibility, and preparedness. By embracing this holistic approach, we can create a safer and more secure environment for everyone. The importance of ongoing education and professional development for electricians and other electrical workers cannot be overstated. Electrical technology is constantly evolving, and it's essential for professionals to stay up to date on the latest codes, standards, and best practices. Continuing education courses, workshops, and seminars can provide valuable opportunities for professionals to enhance their knowledge and skills. Certification programs can also demonstrate competency and commitment to electrical safety. By investing in the professional development of electrical workers, we can ensure that they have the skills and knowledge necessary to perform their jobs safely and effectively. This, in turn, contributes to a safer electrical environment for all. Furthermore, it is essential to foster a culture of open communication and collaboration within the electrical industry. Sharing best practices, lessons learned, and safety alerts can help prevent accidents and improve overall safety performance. Industry associations and professional organizations can play a key role in facilitating this communication. Encouraging electricians and other electrical workers to report safety concerns and near misses without fear of reprisal can also help identify and address potential hazards before they result in accidents. By working together, we can create a stronger and more resilient electrical safety system. In addition to the technical and educational aspects, it's important to recognize the role of leadership in promoting electrical safety. Leaders at all levels, from senior management to frontline supervisors, must demonstrate a strong commitment to safety. This includes providing adequate resources for safety programs, enforcing safety rules and procedures, and recognizing and rewarding safe behaviors. Leaders should also actively engage with workers to solicit feedback and address safety concerns. By creating a culture of safety from the top down, organizations can foster a workplace where safety is valued and prioritized. Ultimately, electrical safety is a shared responsibility. It requires the active participation of individuals, organizations, and government agencies. By working together, we can create a safer and more secure electrical environment for everyone. The principles and practices of electrical safety extend beyond the immediate vicinity of pools and encompass a wide range of applications and environments. From residential wiring to industrial power systems, the same fundamental principles apply. Proper grounding, overcurrent protection, and insulation are essential for preventing electrical shocks and fires in all electrical installations. Regular inspections, maintenance, and testing are crucial for ensuring the continued safe operation of electrical systems. By understanding and applying these principles, we can create a safer electrical environment in all aspects of our lives. The significance of adhering to electrical codes and standards cannot be overemphasized. These codes and standards are developed by experts in the field and represent the collective wisdom of the industry. They are designed to protect people and property from electrical hazard. Compliance with these codes and standards is not just a legal requirement, it is a moral imperative. By following the established rules and guidelines, we can minimize the risk of electrical accidents and create a safer environment for everyone. The advancements in electrical technology continue to shape the landscape of electrical safety. New materials, devices, and systems are constantly being developed, offering improved performance, efficiency, and safety. Solid-state circuit breakers, arc fault circuit interrupters, and smart home automation systems are just a few examples of these advancements. It is crucial to stay abreast of these technological developments and understand how they can enhance electrical safety. By embracing innovation and adopting new technologies, we can create a more resilient and safer electrical infrastructure. The importance of public awareness and education campaigns cannot be overstated. These campaigns play a crucial role in disseminating information about electrical safety practices and promoting a culture of safety within communities. By raising awareness about the risks associated with electricity and providing practical tips for preventing accidents, we can empower individuals to take control of their safety and protect themselves and others from harm. Public service announcements, community workshops, and school programs are all effective ways to reach a wide audience and promote electrical safety. In addition to the technical and educational aspects, it is also important to address the behavioral factors that contribute to electrical accidents. Human error is a significant cause of electrical incidents. Fatigue, distraction, complacency, and lack of awareness can all lead to mistakes that result in accidents. By promoting a culture of mindfulness and attention to detail, we can reduce the likelihood of human error. Encouraging workers to take breaks, avoid distractions, and double-check their work can help prevent accidents. Furthermore, providing training on human factors and error prevention can help workers recognize and mitigate the risks associated with human error.